A very good morning to one and all, and in this particular lecture we will be studying another method for measuring the deviation, and that method is standard deviation. So students, this is the most commonly used method to evaluate, or you can say to measure the dispersion of a particular data. So what is standard deviation? Standard deviation is given by Carl Pearson in 1983, and it is the widely used method in measuring the dispersion. Friends, it is also called the root mean square deviation, and it is denoted by the Greek letter sigma. Standard deviation is the square root of arithmetic mean of the squares of the deviation of the items from their mean. Students, standard deviation is always calculated through mean, or we can say arithmetic mean. So standard deviation is a measure which shows how much variation is from the mean exists. It is based on all the values of the observations. Therefore, a change in even one value, it affects the value of the standard deviation. And the standard deviation, it is independent of the origin, but it is not independent of the scale. Standard deviation, as I said you, it is always calculated through arithmetic mean. Now we will see the types of formula being used in individual series, discrete series, and continuous series. So friends, in case of individual series, we have the formula that is sigma, that is equal to whole under root of summation x minus x bar ka square, that is divided by number of observation, that is capital N. So if we want to calculate standard deviation from the actual mean, we have this formula. But when the arithmetic mean is in decimals, then we can definitely go for the assumed mean formula. So here we have a formula sigma, that is equal to whole under root of summation d square by n minus summation d by n ka whole square. And what is d here? D here is x minus assumed mean. So we can also find the coefficient of standard deviation with the help of this formula, that is equal to sigma divided by arithmetic mean. We can also find out the coefficient of variance, that is equal to sigma, that is divided by arithmetic mean, that is multiplied by 100. So students, in case of individual series, we have this formula. Friends, in case of discrete series, we also have a formula to calculate standard deviation. So first we have to identify whether it is an individual series or a discrete series. In case of discrete series, and when we are calculated the standard deviation from arithmetic mean, then we have this formula sigma, that is equal to under root of summation f, that is multiplied by x minus arithmetic mean ka square, that is divided by number of observation. Students, if your average, or we can say arithmetic mean, is coming into decimals, then we can use the formula this when we can consider the assumed mean in this particular formula. Then we have a formula sigma, that is equal to whole under root of summation fd square divided by n minus summation fd by n ka whole square. And what is d here? D here is x minus assumed mean. And in this formula we can also find out the coefficient of standard deviation, that is standard deviation divided by arithmetic mean. We also have formula for the continuous series. Very good morning once again to everyone. In this lecture, we will be studying one numerical which is based on standard deviation, and somewhere the individual series is given to you. The students coming up with a particular question. So students, we have to calculate the standard deviation. Okay, and we can also calculate, and we have to calculate the coefficient also. Okay, now this is the data which has been given to you. So I am putting this data in this particular row type table, and the variable that is given to you, that is marks. Okay, so first observation is 40, then we have I think 44, and then 54, this is 44, 54, then 60, 62, fine, and then we have 64, 70 and 80, 64, 70, 80, then we have 90, and finally we have 96. So this is 90 and last value is 96. So this is the data what we have, and students, we can see here the variable is marks, and we have to find out the standard deviation and its coefficient. So students, we have given the marks only, and there is no frequency involved in that. So we can say that this data is individual series type data. So now I am writing the formula for standard deviation, and then accordingly we will make the table. So students, first I am writing the formula for the standard deviation, and in case of individual series we have a standard deviation formula. Sigma, basically this is the sign which is used for standard deviation. Okay, this is the Greek letter sigma. Sigma, that is equal to whole under root of summation x minus x bar ka square, that is divided by or I can write here, that is divided by number of observations. Fine. So this is the formula for the standard deviation, and first we have to find out the arithmetic mean, because somewhere in this formula we have arithmetic mean, we also have a number of observations. Fine. So how many observations are there? So capital N is number of observations, and how many observations are there? This is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So in this particular problem we have 10 observations, so capital N is equal to 10. Also we want arithmetic mean, and that is x bar. So what is the x bar? Okay, so even we have to find out the x bar. Fine. So we will make a table first. Okay, we will make a table, and then we will solve this particular problem, and we will come up with the values. Okay, so first I am writing the serial number, that is serial number. Okay, so we have basically 10 values, that is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 values we have, and in the second column I will write marks. Fine. This is my variable, I can say this is my variable x. So first value I have 40, 44, 54, 60, then we have 62, sorry, 64, we have 70, 80 and 90, and we have a 96. So I have written the values here of marks, all the values of the marks I have written. And now looking at the formula, what I want x minus x bar. So first I will find out the summation x, okay. So 10th value is 96, okay. So I will add all these values of x, okay, then I will have summation x, and summation x what we have, okay, summation x, that is 660, okay. If I will add up all these values, then I will have 660 marks, fine. And what is n? Basically n is what? Number of observation, that is equal to 10. And if I want to calculate arithmetic mean here, then the formula for arithmetic mean in case of individual series, the summation x by n, summation x is 660 by 10, that is equal to 66. Okay, now I got the arithmetic mean, and now I will make another column which is x minus x bar. Okay, so now I will make the column x minus x bar. And what is my x bar? X bar is my 66. Fine. So here I will write 40. 40 is the first value of, I can say my variable first value is 40. 40 minus arithmetic mean, that is 66. Then we have 44 minus 66. Then we have 54 minus 66. Then 60 minus 66. 62 minus 66, then we have 64 minus 66, 70 minus 66, 80 minus 66, 90 minus 66, and 96 minus 66. Okay, so I will have all the values I am writing. You can, till that time you can also calculate and write it. So 40 minus 66, that is equal to minus 26. Okay. Then we have 44 minus 66, that is equal to minus 22. Then 54 minus 66, we have minus 12. Okay. Then we have minus 6 here, okay. Then we have minus 4 here. Then we have minus 2 here. Then we have 4, 14, and 90 minus 66, that is equal to 24. And this is what? 30. So these are all the values of x minus x bar. So what I want, basically I want the x minus x bar ka whole square, or then if I will add all the values here, then I will get summation x minus x bar ka whole square. So I will make another column which is x minus x bar ka whole square, right? And if I will add all these values here, then I will have summation x minus x bar ka whole square. This value I will get. So minus 26 into minus 26, basically I am doing the square of x minus x bar. So minus 26 का जो whole square होगा, that is 676. Okay, then minus 22 into minus 22, that is 484. 484. So 12 into 12, that is minus 144. Okay, so minus to हट जाएगा, that is 144. Here you have 36. Here you have 16, 4, 16, and then 14 into 14, that is 196. 196. Okay, so then 24 into 24, that is 576. 576. And 30 into 30, we have 900. Okay, if I will add all these values of x minus x bar ka whole square, and you can write summation x minus x bar ka whole square. So finally I have the value summation x minus x bar ka whole square, that is 3048. Okay, so I am adding all these values, then I got 3048. Okay, so this is the value which I got, summation x minus x bar ka whole square, that is 3048. Fine, putting this value right in this particular formula, so under root the summation x minus x bar ka whole square, that is a numerator, I got the value 3048, and number of observation I know, that is what, that is 10, right. So after solving this, I will get the value, that is 17.43. so this is the value of my standard deviation. In this particular problem, it was being asked that to calculate the standard deviation, and with the help of this particular formula, we have calculated the value of the standard deviation. In this particular problem, we have also been asked to find out the coefficient of the standard deviation. So, what is the formula for the coefficient of standard deviation? So, coefficient of standard deviation, that is sigma divided by arithmetic mean. Fine. So what is the sigma? Sigma is basically white 17.43. Okay. And what is arithmetic mean? Arithmetic mean is 66. So after solving this, we got the value of coefficient, and the value of coefficient of standard deviation was found to be 0.26. So this is the value, that is 0.26. Okay friends, so in this particular problem, we have calculated the value of standard deviation, and also we have calculated the value of coefficient of standard deviation when the individual series is given to us. Okay guys, in the next problem, we will definitely cover the calculation of standard deviation when discrete series is given to you. Thank you.